Hello again. You thought you had a week away from me, but I am haunting your dreams. I'm back. Alright, today I have something else for you to learn. It has to do with the mole, okay? And it has to do with your favorite thing in the world, conversion problems. So do me a favor, write down the I can statement that I have up here. I can convert between moles, mass, and number of particles of a substance. We're going to be able to convert between those three things. I'm going to show you how to do it. Now, conversion problems. You don't have to write this down. You should already have it. If you need to, write it down really quickly. I have a video actually on my website. If you forget about this, go take a look at it. Watch my video again. Here's the things you need, the steps you need to take, okay? Because it's not going to be just simple multiplying and dividing. When we get to stoichiometry, there's a little more to it. And what we do today is going to be a big part of it. You have to have a given. You have to write the final units. We're going to start out, I'm going to show you the conversion factors that you need to know to do these conversions. Okay, that's the one thing you don't know how to do right now is the conversion factors. And then the last thing is you're going to play the game. Cancel out your units. If your unit's on top and you got to cancel it out, you're going to divide it, put it underneath to cancel it out to solve to get to your final units. Okay. So there are going to be three types of conversions that we do with moles. Today we're going to do two of them. I'm going to show you all three. The last one I'll talk about when I get back. First conversion you need. 1 mole equals 6 times 10 to the 23rd. That's 6 with 23 zeros at the end. Much too big a number to comprehend. So here's one of your conversion factors. 1 mole is 6.02 times 10 to the 23rd representative particles. Okay, so if you have an element, the representative particle will be atoms. If you have a molecule, your representative particle will be molecules. So you got to take a look at whatever substance you're trying to find. It'll tell you what your representative particles are. Okay. Also talked about this yesterday, and you know how to add up and get your total mass, molar mass. Sorry. You just look at the periodic table. 1 mole is going to be the mass from the periodic table expressed in grams. Molar mass, that's what this is. Molar mass. Okay. And the last kind of conversion with moles, I'll show you how to do this when I get back. It's probably the easiest thing anyways, so don't worry too much. 1 mole of any gas, whether it's carbon dioxide gas, methane gas, hydrogen gas, helium gas. 1 mole of any gas occupies 22.4 liters of space at STP. I'll tell you what STP is later on. You have a standard temperature and pressure, meaning this isn't true if you change the temperature or the pressure. There's a set standard. Don't worry about that, just write it down for now. So now what I'm going to expect you to do, if I give you moles of something, or mass of something, or a number of particles of something, you're going to be able to convert that to anything else that I want there. Okay. Let's go through that example that I have on the worksheet. It has to do with water, H2O. Let me do my notes here. And the example question reads, how many moles does a glass of water contain if the mass of your water is 150 grams? There's the question, okay? So, you follow your steps that I told you about earlier in the year. You read your question, you find the given. What value does the question gives us? it gives us 150 grams, and it's 150 grams of water. Write that down all the way to the left. And I said, put it over 1 if it makes you feel happy. This is all part of the game for crossing out units. Okay? So go ahead and do that as you're given. Your final unit here, okay, we want to know moles of water. Okay, our final unit, moles of H2O. Write that down all the way to the right. Leave a little bit of space there. Now, here's the thing. Here's the important thing. You got to have your conversions. And for moles of water, there are 2 of them that we care about. Okay? So I'm going to write them both down. We'll see if we need one or both of them. Okay? So we know 1 mole of water. Okay. It's a number of particles. It's 6.02 times 10 to the 23rd molecules of water, because H2O is a molecule. We also know that 1 mole of water is whatever's water's molar mass from the periodic table is. We're going to add up the hydrogen, 2 of them, 1 oxygen, okay, and that's the molar mass. 1 mole of H2O equals, if you remember from yesterday, 18 grams. And not 18 grams of anything, 18 grams of H2O. Okay. So, which one of these do I need? Do I need them both? I need a conversion that has grams of H2O and moles of H2O. Lo and behold, this one has it. I don't need to use that at all in this particular problem. So you know how you play the game. We got to cancel out grams of H2O. So that's going to go on the bottom, 18 grams. H2O. And whatever's on the other side of your conversion factor, you're going to put that on the top, 1 mole of H2O. So what happens to my units? Grams of H2O cancel out. In order to solve this problem, it's 150 divided by 18. That tells you how many moles of H2O are in 150 grams of water. And when I put this and calculate it out, I want to have 2 significant figures because my given only has 2 significant figures. Okay. We're going to say 8.3 moles of H2O is what you should get when you put that into your calculator. Okay? Follow the steps I taught you at the beginning of the year. The only thing new is these conversion factors. So the top one, 1 mole, is 6 times 10 to the 23rd particles. The bottom one, 1 mole, is your molar mass from the periodic table, and it's grams. Okay? So we're going to do another one. Actually, I'm going to start you up with the first problem. Okay? I'm going to let you solve it there. Okay? If I can find my eraser, I'll be right back. And the first problem on that worksheet says how many atoms are in 48 grams of silver. Okay? So let me write that in that question. So Step number 1, find your given, write it all the way to the left. There it is right there. "48 grams of silver." Put it over 1. Okay. What final unit do I want to end up with? What is my question asking for? Asking for how many atoms? So I need a number of atoms. My final unit is number of atoms of silver. So let's write down our conversion factors that we need. Okay. Now here's the thing. We need to use mole to get from grams of silver to atoms of silver, because the mole is what helps us convert between these things. All right? So I know 1 mole of silver is the same thing as 6.02 times 10 to the 23rd atoms. Silver is an element, so its representative particle is the atom. Okay? This is good. That's what we want to get to. So that's very, very helpful. The only thing is, I still don't have anything to start out canceling my grams of silver. But here's the thing. I know 1 mole of silver. If I look at the periodic table, it's going to tell me how many grams are in 1 mole of silver. And that was 107.9. Good, good, good. Now I have something I can start with, because I got to cancel out the grams. So we're going to use this conversion first. I always ask you, what goes on top, what goes on the bottom? I'm sure some of you can already get started on this. 1 mole of Ag. This side here goes on top, and the other side goes on the bottom. Because the whole point is we got to cancel out grams of silver. So it does. All right, so if I stopped here, my units are how many moles of silver are in this many grams. And I don't want that as my final answer. I want to figure out how many atoms there are. So I got one more step I have to do, and it's excellent because I have moles of silver and atoms of silver, and that's what I got to fix. So this side of the equation goes on the bottom. Okay. This right here to cancel out that. And then your other side goes on top. And to solve this, what you're going to do, multiply 48.0 times 6.02 times 10 to the 23rd. Don't forget about your big exponent there, divided by 107.9. I'm going to let you do that. Give you a hint, it's going to be a really big number. And hey, I'm taking it easy. That's all I have to say to today. I'll miss you until next week.